Welcome to the audience. In this presentation, I'm going to show you a technological outline of our project work named EvilStore. The project has made by a 4-member team named Eclipse Evil Edition. This slide shows the names and the contexts of the members. The assignment was to develop and implement an online application store in model-driven paradigm using service-oriented architecture. This was a homework from the model-driven development and system integration courses led by the Fault-Tolerant Systems Research Group in Budapest University of Technology. The goal was to create a system where third-party developers can register and publish their applications. The uploaded applications undergo a serious quality assurance processes, which contains both automated and manual validation techniques executed by the administrators of the EvilStore. Users also can register to the system and browse the validated applications. If a favorable offer is found, it can be bought and later downloaded. The cost of the product is subtracted from the account of the customer and transferred to the account of the Evil system and the developer. We have created a metamodel to develop the structure of software components and the provided services. The complex business entities are also defined in this. We used the entity modeling framework to define this metamodel and generate an editor to design the application store. The instance model needs to satisfy some constraints. To define and check those constraints, we used the EMF inquiry technology developed by the teachers of the courses. This high-performance incremental graph matching engine finds the negative constraint patterns of the instance model and emits it as a warning or error. We defined constraints like the acyclicity of the inheritance tree, the uniqueness of attributes, or simply the format of the name of the object. When the design is finished, the developer may initiate an automatic code generation process by a simple click on a button. We have put great care to this generation. All of the projects and source files are created for multiple platforms. Only the business logic of the services are needed to be implemented. In the long run, this investment greatly increased our productivity. For this task, we used the extend template-based code generator. In this distributed system, the services are provided by software components. Those components can run on different servers and can be implemented to different platforms or in different program languages. The communication between those components is defined as RESTful web services. The binding of those services to manually implemented functions is provided by generated code. A standard serialization data format capable of describing complex entity structures is needed for communications of the software components. For this purpose, we choose the JSON format. The serialization and deserialization is done by generated code, so the editable part contains only strongly typed functions. For the serialization, we use the Jackson JSON and the Newton JSON technologies. After the components are developed and most of the code is generated, the implementation of the services was an easy task. The changes in the design can be easily derived to the implementation by the regeneration of the unedited source files. The OSGI components are run in Jersey servers, the .NETs are in IIS. The business entities of the system are needed to be persistent. To solve this requirement, all non-temporary business entities persisted to database. The binding of the classes to database tables is also generated. The services are transactions over the entities, so the begin and the end of the transactions are also generated. It's possible to define database queries of the services. When it's used, the queries are also generated to the function. We used an Apache Derby database and the Java Persistency API for the database binding. A requirement was to create a service to highlight some product for the user. The highlight was defined by frequently changing rules. Defining and executing this rule-based business logic, we use the rules technology. The rules are in if-then format. For example, if a product is recently purchased or purchased by a similar user, the highlight score of the product is increased, but an age restriction rule can permanently remove the product from the set of the highlight candidates in case of an underage user. From a product like this, the high maintainability is a usual requirement because the business logic should be easily changed by the management. For this purpose, we used the BPMN2 technology to define the workflow of the business logic. This notation provides an easily understandable and modifiable workflow graph. The services of the system are integrated into workflows, which contains both automatic, such as code verification, and human tasks like user registration. Those workflows are executed by JBot's GPPM5. At the end, every technology are successfully integrated into a working project. Thanks for the listening. The most important contacts are available on this slide.